Hey, welcome back to the channel. My name is Tony, and today we're gonna cover another problem, 131 palindrome partitioning. So let's go ahead and read the question. Given a string S, partition the S such that every substring of the partition is a palindrome, and we're gonna return all the possible palindrome partitioning of S. And a palindrome is a string such that when you read from forward or backward, you got the same thing. So let's go ahead and read one of the question. Uh, Read one of the example right here. So initially we have the AAB, and this is gonna be the initial inputs. And how are we gonna split the substring into different substrings to make sure each substring is gonna be a palindrome? And the easiest way, which is the option number one for all the cases, is gonna be we split from each individual character. So we're gonna split as A and B. Each individual character is a substring, and it's gonna be a palindrome for sure because we know it's a single character. And the second option in this particular case we have is like we split right here between the A and B because we know A and A are identical. So if you revert it, and then A and A is gonna be remain the same, and then we're gonna put B in the end. So that's the second options we have, and that's what we have in the result. And without further explaining the example, I think we got the idea. And how do we gonna approach this in the bigger example? So let's go ahead and read another example right here. So for example, we have a whole bunch of A in the beginning, and then we have like 3x in the middle, and we have B, and we can have like a whole lot of like other characters in the middle. I'm just gonna represent it by using X. And how do we like approach this problem? And the way we're gonna approach it is by using backtracking. And the reason we can use exhaustive search by using backtracking is because we know the data size is very small, so we can just do whatever we want with the data size. And to do the 16 power is fairly doable within these cases. And how do we like using the algorithm backtracking to try like all the possibilities? And the easiest way, and we know that we have to do that, is by splitting for every single element. And we can take A out, and then we can take the rest of the characters into the second substring, and we're gonna recursively solving the problem. And we treat the second part as the original input, and that's recursion is gonna deal with that. But the first part, we just take this guy out, and then we check if this guy is a palindrome or not. So we know this is a palindrome, so we can keep going forward with the recursive function, checking the rest of the substring. And then we can check the second one, which is we put the first two characters out, and we check if this guy's a substring, or if this guy's a palindrome or not, and then we recursively deal with the rest of the substring. And same thing, we can keep going doing this. And we take the first three characters out, and we recursively check the rest of them. And same thing right here, we take the first four. Oh, here's a really bad example actually. So you know what, so since we already have this example, let's just keep going forward. um Check one more, and like right here, so we know that this guy is not palindrome, so we are not gonna keep going for forward and checking the recursive function for this guy because we know that this guy failed. And that's why we can just save some time by doing initial checking for the left part, which is the smaller chunk of the string that we initially check. And we're gonna use recursive function to check the bigger string that we left over. And that's how we're gonna do this. And the reason we can do this is by using the helper function, checking the initial palindrome, that initial string that we split out, is that even a palindrome? If it is, we can use recursive function to deal with the rest. And then so for each split, and we're gonna use a recursive function to keep going, and the backtracking can and gather all the possibilities, and we're gonna use a result array to storing all. It's more like a list actually. So we're gonna use a result list to storing all the possibilities we have. So we can initially split from here, or split from here, or split from here, and split from here, and keep going forward, and stop right here because we know that this guy, stop right here actually, and we know this guy is not a palindrome. And so what do we do like when we're going forward? So for example, that we kick this guy out, we know that this guy is a palindrome, so we're gonna store this into our result. And the rest of the string is going back to the recursive function, so we're gonna treat this guy as a new function in the next layer. So we're gonna keep going, and then treat this guy as the original input, and then we can split right here, and we can split right here. And keep going by using the exhaustive search, which is the backtracking. So now we know the method, so we're just gonna code it up. The initial input we have, oh no, not the initial input. The final result we have is the result right here, and then we're gonna use the DFS recursive function to recording the result, and we're gonna have s, which is the input, and we're gonna have the empty array and temporarily store the things we kicked out right here. So we're gonna check if this guy is a palindrome or not. And then eventually we're gonna return the result, and then we're gonna write down the recursive function to solve the solution. And we know the initial input is s, and the temporary array, the list, is going to be a path. And then we also have the final result. And then I'm going to modify on top of the string. So that's why like my base case is going to be checking if the string is empty or not. So we can come back to this. And so we're going to split from every single characters. And so that's why I'm going to loop through the entire string and +1. And so we're gonna split right here, and we're gonna split right here, we're gonna split right here, all the way to the end, to the last one. So on the Python, like when you doing the string slicing, for example, like you have xxx and a is gonna be a list and something like that. And so when you do all the way to 2, like, so it's gonna cover only the first 2 parts. And that's why when you do the indexing, this is actually the 1. So that's why we have the increments right here. So that's why we have the increments right here. And once we have that, and we can keep going and doing the DFS, which is the backtracking, so whatever you name it. And we are going to take the first chunk. The first chunk that we split is by using the index I, and the I is gonna be looped from here all the way to the end. So that's why the rest of the string is gonna be the new input, and the rest of the string is gonna be string slicing from I all the way to the end, and that's what we left over for the original input. And then like there are 2 ways to do backtracking in Python. So I'm gonna use one way here. So I'm gonna explain the different ways uh, at the end of the video. So it's just very simple modification. And we're gonna have the path right here, and to plus the string that we kicked out for, it's gonna be the first chunk. So A or AA or AA. So we're gonna try all the possibilities. So we're gonna split from every single position and try to all the possibilities to check if we can split and this guy as a palindrome or not. So that's why before that, so we have to check if is palindrome. So let's just call this guy is Paul. And so we're gonna check if the first part, the first small chunk we kicked out, is gonna be a palindrome or not. If it's a palindrome, so we can going forward and checking the rest of the string. If not, so we're not even gonna touch it. Yeah. So I think this part like we already done, and the only part after is gonna be the base case. So if the string is empty, so which means that we do not have anything left over in the string, so that means we are already finished the processing. So by the time of that, so we can put the path in, and then we're gonna do the return, and we are not done yet because we still have the is palindrome to check. So I'm just gonna use the easiest way to check. Of course, you can use dynamic programming to check as well, to checking if a string is palindrome or not, and that will be like accelerate the speed. But in this case, I'm not gonna do that, since it's very easy to use the brute force way to checking the palindrome. So now we're checking the palindrome right here, and then if the first part that we split out is going to be a palindrome, so we can keep going forward with our recursive function, which is the backtracking part. And let's go ahead and run the code. Wow, this is not right because the isPal is, the naming is wrong. Okay. I think this will work, and there's another way to do that, and typically I think in Java or like C++, and people usually do that is by using path append, and we're gonna append this part because we know this is backtracking. So basically we literally just add it and pop it back right here. But in this case, like we have to put 2 dots, which means we're doing some sort of copy right here. And this is also works. So imagine if you don't put the copy right here, and this will fail. It's gonna be a empty result. And the reason this happens is because the previous way, that when we actually doing the modification on top of right here, and when you're doing the concatenation right here, is because when we do this, and this will create a new copy. This is actually um, passed by value instead of passed by reference, and that's why we have the new copy right here. And so we don't have to put two dots right here. But in this case, like, we actually pass by reference, and we know that we actually pass by uh, we are actually adding right here, and that's why you have to do some sort of copy right here, and to make sure that data is there. And yeah, that's gonna be the end of this video. So if you guys have any comment or questions, so please leave the comments in the below video. I'll see you guys in the next video.